let the panel here introduce themselves.
My name is David Raper. I'm from the Australian Securities Exchange. We run an equity market and a futures market, and I'm responsible for those. We also have a co-location facility and our own domestic and international networks. So I'll be talking about those today.
Well, my name is Dan Spivey. I'm the founder and CEO of Spread Networks. We have the shortest fiber optic path from New York to Chicago. We also have a new wireless product coming out from Fork 1400 Federal to NY2 and NY4, and that will be out on June 30th.
My name is Saul Umbrasas. I'm responsible for products and sales marketing and event communications. We're about a 10-year-old company doing only millimeter wave wireless equipment for both sort of telecom service providers and financial services. So, and I'll tell you a little bit more about millimeter wave later.
My name is Jay Lawrence. I'm the CEO of NexComm Wireless. We are a service provider similar to Spread. We use a hybrid of millimeter wave, microwave, and fiber in our networks. And we service a lot of folks in the low latency space, but we also have a practice that is outside of that, more of a carrier model. But in any case, we view ourselves as a technology-enabled service, and we focus on niche, high-performance solutions.
Okay, let's start off with something kind of hopefully everybody knows about, which is optical, and then we'll move into the fiber technologies. But Dan, can you tell us about what are the advantages and where the fiber optic networking plays, and what people are using it for to get an advantage in the high frequency trading area?
Yeah, so the main advantage that fiber gives you is you have a lot of bandwidth, and therefore it's not great just to have bandwidth for the sake of having it, but it really comes into play when the markets get loud. A wireless network works very well in a quiet market. It may not work quite as well in loud markets. Fiber works the same whether or not the markets are quiet or loud. So what that translates to is it allows you to clearly see, what's happening in the market. You don't lose packets. You don't have kind of that oh shit moment, during a microburst, and it's just a nice clockwork tool. And then we have several levels of latency. There's a large premium for our fastest fiber, and then we have a second and third levels that are cheaper. Well, so folks will pay for a faster fiber.
Okay. So in contrasting that to some of the wireless technologies, Jay, where do you see microwave coming into play, and why?
Let me start by expanding a little bit on what he was just talking about too, because there is one other very valuable component to fiber networks that we use regularly, and that is diversity. We have a lot of clients who need to have, they need to know that they're going to be up. You can't get that with one medium. Wireless won't do it by itself. Fiber can't do it by itself. You always have the backhoe takes the fiber out, the rain takes the wireless down. Usually they're not working at the same time. But I think that's an important building point. But for us, we're deploying both microwave and millimeter wave from a radio standpoint. We've also done it collectively with fiber, so kind of another component of wireless fiber cooperation. You hear folks talking about ocean crossings, and I sat on a panel last year and there was talk about using balloons and dirigibles. My comment there is that's an expensive truck roll when the radio goes down, which it will. But when you are looking at those kinds of geometric situations where you have to go under or around a large body of water, fiber and wireless play very nice together, and the two can take advantage of the physics where, to Dan's point, you are going to be capacity constrained in wireless. There's a scarcity to it. It's a function of channel size, it's a function of bandwidth that are really limited, whereas fiber does have that infinite component to it. But where we're deploying networks, and last year we lit the New York to London via the subsea cable. That's been live for a year, so it's a great example of cooperation between wireless and fiber. We've got 100 megabit wireless tacking onto it and shaving what would have been about 2 to 3 milliseconds off the old all fiber route. But you do have that constraint. You have customers using an entire fiber route for bigger capacity and more uptime, but there is that premium service where you're only getting tens of megabits. So I think the key point that we see as we look at deploying these things and implementing them is the right tool for the job. We've seen a lot of folks try to put square pegs in round holes, and that's never good for the peg or the hole. But I do think that the market has learned a bit and matured both in terms of radio technology and how to deploy it, and making sure that specs go from good concept and design to a useful service to the client.
Saul, how about the millimeter wave? How's that? Can you kind of compare and contrast that versus microwave or even to optical?
Sure. The millimeter wave is wireless technology, obviously, and it's, if I can say it, it's kind of a little bit in between the optical and microwave. So microwave been around for a long time. Millimeter wave, FCC opened only in 2005 for commercial applications. In Europe opened in 2007. First commercial systems sort of emerged right around the same time. And as you heard Jay mention that, for example, they feed fiber with wireless, if I can say that way. And the feed on microwave was about 100 megabit. So the advantage of millimeter wave is really that we can get significantly more bandwidth. So on one radio, on one channel, today we provide gigabit capacity, and we can cross-polarize that. And so basically on the same antenna, we can provide 2 gigabits. Then we have other systems that's more applicable for slightly higher latency application, where we have literally software provisionable radio going from 100 megabit to 3 gigabits and higher. And we're building now, for example, 10 gigabit millimeter wave radio. So the advantage of, well, because the difference with millimeter wave versus microwave is, first of all, we provide 10 to 20 times more capacity. The disadvantage is that our distances are shorter. So millimeter wave is much more suitable for the natural applications where you have actually a lot of traffic, a lot of traffic going between different data centers. And it's not economical, at least today, to build millimeter wave, or for example, from Chicago to New York. But in all the financial centers of the world, I would say millimeter wave is definitely dominant technology over the microwave. But I would not get offended if you say millimeter wave and microwave are similar. It's okay.
Actually, there's one other advantage that millimeter wave does deserve, and that is because of the simple mechanics through the modem, it can actually operate in a mode that really minimizes latency while keeping it an actual radio. In microwave, in order to optimize, there's some trickery that has to be done, typically putting in some sort of a repeater. Downside of repeater is you're not reforming the bits going through it, so you're strictly in the RF mode. Whereas in the millimeter wave form in metro markets, you can have something that stamps and reforms ones and zeros at every site while not paying a big latency penalty. That does not work mechanically in microwave. So it's a trade-off in design, but it is a really nice feature for a metro market. And when you are focusing on low latency, if you're in metro, the last thing you want to deploy is microwave. You want to keep millimeter wave in your foreground.
Okay. So, Dave, I'm a trading firm. All I want to know is I want to minimize my latency, right? And that means I've got to co-locate, and there's all these vendors out there telling me I've got the fastest fiber, or you should be using wireless technology here, whatever. And I go to the exchange, and the exchange then has to deal with all these vendors who want to get in there, and all the customers who want various technologies. How do you guys manage that from both a vendor point of view and a customer point of view, and how do you kind of keep a level playing field on both sides?
Yeah, it's an interesting question. The level playing field thing is something that we focus on a lot. We provide open infrastructure, so you can connect on whatever network you want, or you can go on the network that we provide. Within our co-location, we provide all the connections, so we essentially neutralize latency within the co-location facility. And then we look at things like millimetre as well. So there's a second exchange in Australia, and we'll use millimetre to move our data and their data between the data centres at the lowest speed possible. What that's all about is ensuring that our users within that colo get access to the fastest data that they can. So we really look at it from a democratic perspective. We're trying to get as many people as possible onto the fastest service, if that's what they choose to use. They can use something else, but we're trying to make it commercially accessible to them. The vendors are always looking for an edge. They're also always looking to have the fastest service, and that's really for them to sell. But we'll make sure that the fibre network that we operate and the millimetre solution that we put in place are the best solutions that are in the marketplace.
Now, where are you using the wireless? Because I can see, there's the play within New York, there's the play between Chicago and New York, and then now they've also done 350 CERMAC with ICE versus DC3 with the CME. Where are you guys using?
So we've got our own co-location in the north of Sydney, and we've got the futures market in there, the options market, and the vast majority of the equity market. There is a second equity exchange about 10 miles away. People trade between those two exchanges. So we started off with fibre, and people have started using millimetre between those. And we're in the process of putting our own millimetre service in place to move the data across once. Because at the moment we've only got 3 or 4 customers that are using that service. So we want to now make it available to everybody.
Okay. So, I mean, maybe the comment you just made begs a question. It's probably obvious to everybody, but why do I want to use this wireless in like a New York metro area? There's plenty of fiber there. As a trading firm, what's my strategy that I might want to pay more for and get less bandwidth or whatever to leverage it? Anyone of you guys?
Yeah, I'll start off since I'm at the anchor here. For the traders that want latency, that's the reason they're going to use it. Is wireless has the physical benefit of being 40% faster in the air than the glass. The question after that is how efficient is the path and how useful is the radio. Although the radio is becoming a smaller part these days because they've been so optimized, really it's path, and you can just get a straighter line and you get the air versus the media loss factor in the glass. The other bit that I hit on earlier, which we do a fair amount of for clients, is diversity. And even though there's fiber everywhere in those metropolitan cities, when Sandy came in a couple years ago, it was a great example. We were covering Verizon clients for the better part of several weeks because we were down when it rained, but generators came back up straight away, and people were talking. So you look at those kind of give and takes. But for the trading community, it's no big secret anymore. It's all speed.
So yes, as you mentioned, the wireless is basically about 40% faster. So that's how much is basically lower latency. So we have equipment, for example, now that delivers multiple gigabits with like 10 nanoseconds of latency for about 10 miles, then plus air absorption, whatever. But it's very low latency. But in addition to that, the wireless gives advantage of basically you can get to revenue or to service much faster. Fiber optics typically still takes lots of permit work, particularly in urban areas, and time to dig the trench or pull it through some sort of conduit. Wireless, if you actually have line of sight and you have rooftop access, you can set up multiple gigabits of service within one day. So several months versus one day, you can generate revenue much faster. So these are the advantages.
Okay. But I think Dan alluded to this. Some of the wireless technologies I've seen, or the vendors will sell you the bandwidth based on so and so many megs or whatever. And obviously you don't want to pay for more than you have to, but there's always the fear of the microbursts. So, the FOMC comes out, or they decide to move the rates, and all of a sudden, there's big spikes in data. So, Dan, can you speak to that? Obviously, you have bandwidth issues.
Well, I mean, it's simply a matter that Yeah, it all depends on what you're trading and how you go about it. There's a lot of guys out there that are just fine. They buy wireless and they get slower fiber. You know, for a large trading group, it's very hard to run an entire you know, trading group on, you know, 10 megs or even 100 megs. We have guys that have several hundred megs, you know, that on a wireless platform that would still pay a premium for our fastest fiber. It's, you know, and it's not just in, you know, a few announcements once a quarter. Many times it's on the open and on the close also. And again, it really just comes down to what you're trading. If you find that you're, you know, not making a lot more money when the markets get loud, then you may be leaving some money on the table. Maybe just try our product. You know, for those who are on our fastest fiber, I believe they look forward to loud markets because they make a whole lot more money in a loud market than
When there's
a quiet.
economic number that's, where you see a lot of volatility and a lot of opportunity to make money, I guess. We've kind of alluded to several issues or maybe addressed them, but even within the wireless technologies, there's differences. Some are more susceptible to weather conditions and so forth. And then there's the comparison between the two, which we talked about a little bit. But can you guys talk about the issues if I put up wireless? We've kind of alluded to the fact that I need to have both for both diversity in terms of loss of service or weather conditions.
Yeah, I'll start and I'll let Saul take the second competitive. But as I see it, there's three core sciences that are used in free space communications. You have microwave, which is commonly defined as below 40 gigahertz in spectrum. You have millimeter wave, which the useful millimeter wave is between 70 and 90 gigahertz in spectrum, which is the kind of product that Saul's business builds. And then you have optics or free space optics, laser comm, call it what you will. There are all three being used today in some form, or at least attempted to do low latency networks and other networks. But there is a general truth with wireless communication. The higher you go in spectrum, the shorter you go in distance is a typical truth. Also, the higher you go in spectrum, typically the more bandwidth